Greetings to every one of you. So in this video we are going to discuss another important concept from data structures and algorithm, that is quicksort. Quicksort uses the divide and conquer technique. The key process of the quicksort is called the partitioning. The partitioning can be done with the help of a pivot element. The pivot element is a element that is selected from the given list. So by partitioning, the pivot element can be placed in the appropriate position in the array. We can select any element as a pivot element and we will place that element in the appropriate place in such a way that the smaller elements than the pivot element will be placed on its left hand side. The larger values, larger elements than the pivot element will be placed on the right hand side. See, for example, if I say this is the pivot element and all the lesser values may be on the left hand side, will be on the left hand side, all the larger values than the pivot element will be on the right hand side. So this portion is called partition 1 and this is called partition 2. Again, if the values are not sorted, again we have to do the procedure on this partition. So again we have to do you can select any one of these elements from this partition, from this list. You have to perform the procedure again. Similarly, on the partition 2, you have to select any part that is a pivot element. Again you have to do the process of the partitioning on the partition 2 till the entire list is get sorted. Now let us see how actually this algorithm works. So here consider the left value, it is nothing but 20. So the pivot element is equal to 20 here. Okay. Now L is equal to left plus 1. So left is, that is 0 plus 1. So L will come here. And R is equal to right. So right is 7 and that will be, that is R will come at the location that is 7. While L is less than R, do the following. In the first while loop we are doing this operation, that is while L less than right. And another condition you have to check that, and A of L less than the pivot value. So two things you have to, that is combine together. So while L is less than right and A of L less than pivot, increment the value, that is L is equal to L plus 1. The second condition is that while R is greater than left and this A of R, it is greater than the pivot, set R is equal to R minus 1. Here we incremented the value, that is L, and here we have to, that is decrement the value, that is R. The third thing is to check the condition, again the same condition. If L is less than R, swap this A of L and this A of R. The third condition, if this condition is false, that means that is L is less than R, we have to perform this, swap the value of, that is A of L and A of R. If this condition is false, we have to do the operation, that is store the pivot value, that is in that A of R. So that can be written as A of left is equal to A of R, and in A of R store the value, that is pivot. So it means you are swapping the value of pivot with the value of R, A of R. So that is the end. So this is the algorithm, and now let us see how this algorithm works in this with the help of this example. So now actually this value 26, it is greater than the pivot value. Stop incrementing, you need not increment now. So what you have to do, you have to check the next side. So here check the value, that is 15. The 15, it is lesser than 20. Okay, it is lesser than 20. So this being the case, what you have to do, you have to swap these values. A of L and A of R should be, that is swapped. So this is 15 will come here and 26 will come here. Okay, remaining other values are that is same. It is 22 and this is 25, this is 16, 13 and this is 19. Now the position of this pointer, that is L, is here and R value is here. Again you have to check the condition, that is 15, it is greater than 20. Now increment the value of L. Now you have to increment. So L will come here. 22 greater than 20. Yes. So now what you have to do? Go to other side and check the value of R. Okay. You have to check for the lesser value. Okay. 26 lesser than 20? No. Decrement the value of R. From 7 it will become 6. Okay. So now 19 is lesser than 20. So what you have to do? You have to swap these two values. Okay. A of L, this is this is A of L and this is A of R. Swap these values. 19 will come here, 22 will go there. Remaining all other values are same. This is 15, this is 25, this is 16, this is 13 and this is 26. Is that clear? So now the current position of the pointer, that is L is here and R is here. Okay. Check the value, that is 19. Is 19 is greater than 20? No. Increment the value of L. It is incremented. Go to the next level. Now 25, it is greater. So stop incrementing. Stop here. Go to other side. Check the value, that is 22. It is lesser than 20? No. Decrement the value, that is this is R minus 1 here. Now check, now what you have to do, 13 is lesser than 20. So what you have to do, you have to swap these values, that is A of, this is A of L and this is A of R. 25 and 13 will be swapped. 13 will come here, 25 will go there. So remaining other values are same. This is 19 and this is 16, this is 22 and this is 26. Is it clear? Now the current position of L is here and this is R is here. Now check this value, is 13 greater than 20? No. Okay, increment the value. So L will comes here, L will comes here. 16 greater than 20? No. So automatically it will be, that is incremented, it will come here. Similarly R value, you have to decrement the R value. So R is now current value, it is greater than 20. You have to check for only the lesser value. Okay, so decrement the value of R. So R will come here. Okay, 16 is lesser than 20. You can stop here. Okay, so from for R you have to, that is check for the lesser value. For L you have to check for the higher value. But here what happens, this R and L crosses. So this being the case, we have to, that is do one thing. So actually I said, if L value is lesser than R, we have to swap this. Here this condition, what is that? This violated. The condition, this particular condition is violated. That means what is that? Value of R, value of L, it is greater than the value of R. That being the case, what you have to do? You have to swap the value of pivot element with the A of R. That is what actually I have done here. So A of R is stored in, what is that? This left, okay, and the pivot element is stored in A of R. So what is that? This is the left element. Okay, so 20 is here, and what I have to do? I have to, that is store this 20 here, and 16 should be, that is stored here. Remaining all other elements are as it is. This is 13, 25, this is 22, this is 26. Now this is the pivot element. This is the pivot element, and check that all the elements on the left hand side are lesser than 20 and all the elements that is on right hand side, they are greater than 20. Okay, so now this is one partition, this is another one partition. This is why actually the technique is called partitioning. Now you have to apply the same procedure on this partition as well as this partition separately. Okay, so consider this is 16 and this is 15, 19 and 13. Okay, so have a separate partitioning technique. So consider our pivot element, this new pivot element is 16. Consider this is 16. Okay, so here is here and that is incremented here. So check that 15, it is lesser than 16. So again increment the value, L will come here. Check that. Similarly, this is R and R value that is lesser than 16. So automatically what you have to do? You have to perform the swap operation. This is A of L and this is A of R. You have to swap this value. 13 go there and 19 will come here. This is 15 and this is 16. Okay, so L is here and R is here. Now increment the value of that is L. Move the value of L. Okay, L will come here. What about value of 19 is greater than 16. Okay. Now what you have to do? You have to decrement the value of R. Decrement the value of R. R will come here. Okay. So in this case, L value is greater than the R value. If L value become greater than, if this condition is false, what actually I have done here? We have to swap the value of R with the pivot element. So what will happen? The pivot element will come here. This value that is A of R will go there. So remaining elements are that is as it is. Okay, so our original value that is 20 is here, that is a pivot, original pivot element, and now you can see that this list is gets sorted. Okay, so similarly you take this element, this particular portion, this is 20, this here you take this particular list, this is 22 and this is 26. So our pivot value, consider the pivot element as 25. So this is L value. So we start from here. Okay, L that is 22. It is lesser than 25. So move on to next position. This is L. 26 is greater than 25. It's okay. But previously R is here. Decrement the value of R. 0, 1, 2. Decrement the value of R. R comes here. So automatically L crosses R. So what you have to do? You have to swap the value of A of R with the pivot element. The pivot element is 25. So 25 will come here. 22 will go there. This is 26. It's sorted. So what actually you have done the procedure you recursively you have to do till you are getting that numbers or get sorted. You have to that is do the the process again and again. It is a recursive process. So that that portion what actually how we can do the recursive procedure, it is given here. They have this quick sort. It is a procedure. Array left right. If this left value it is lesser than right, the P is the partition which contain the array left right. So this is left and this is right. So what we have to do? We have to start it from the array that is on the left hand side, that is left, up to you have to that is go up to that is what is that? This is P. So this is P minus 1. Okay, isn't it? This is P minus 1. So this is P plus 1. So this is left, this is right. Okay, so from left to P minus 1, okay, you have to perform the quick sort, the procedure quick sort. Then from P plus 1 to right, from P plus 1 to right, you have to perform this. So this is a recursive procedure. What actually I have done, it is given here. Okay, and talking about the time complexity of this quick sort. That as for time complexity is concerned, the time complexity it is order of n log n. It is n log n for the best case. You can say best as well as the average case. As well as the average case, we will have order of n log n. The worst case, what will happen, since we have two loops, the worst case will have order of n square. So I hope you understood the concept of quicksort. I explained what is a procedure, and I explained the algorithm as well as the recursive procedure, and I explained the algorithm with the help of this example. Thank you for watching.